Balancing of chemical equations. That is the topic of today's lesson on chemistry. Balancing of chemical equations. First of all, what is a compound? In your junior secondary basic science, you were taught that a compound is formed when two or more elements are chemically combined. For example, the compound on the board here, sodium chloride, is formed when sodium is chemically combined with chlorine. The compound sodium chloride is formed. What then is a chemical equation? A chemical equation is a representation of the reaction which leads to the formation of a compound, as can be shown on the board here. Sodium reacts with chlorine in gaseous form to produce sodium chloride in solid form. This is a chemical equation. Is it balanced? What do we mean by balancing of a chemical equation? Balancing a chemical equation is a practice of making sure that the number of atoms of a particular element on the reactant side is equal to the number of atoms of that same element on the product side, the right hand side. Again, to balance the chemical equation means to make sure that the number of atoms of a particular element on the reactant side, that is the left hand side of the chemical equation, is equal to the number of the same element, number of atoms of the same element on the product side, that is the right hand side. Let's take this equation on the board, for example. On the left hand side here, we have one atom of sodium. On the right hand side, the product side, we have one atom of sodium. So atoms of sodium are balanced. Chlorine. We have two atoms of chlorine on the reactant side. On the product side, we have just one atom of chlorine. Is chlorine balanced in this chemical equation? No. How can we balance it? Should we just put a subscript 2 here so that it's going to be two atoms of chlorine on the reactant side and two atoms of chlorine on the product side? No. We do not use subscripts. The small number here that we call subscripts, we do not use them in balancing chemical equations. I'm going to remove it. What then should we use to balance chemical equation? We use coefficients to balance chemical equation. On the board here, on the reactant side, we see two atoms of chlorine on the reactant side. To balance it, I'm going to use coefficient 2 here. This 2 is affecting both sodium and chlorine because sodium and chlorine here are chemically combined. They make up one compound. So let's check again. On the reactant side, sodium is one atom. On the product side, sodium is 2 times 1, 2 atoms. So I'm going to introduce another coefficient here, 2. 2 times 1 here, 2 atoms of sodium on the reactant side. On the product side, 2 times 1, 2 atoms of sodium on the product side. So sodium is balanced in this equation. What about chlorine? 2 times 1 here, 2 for chlorine on the reactant side. Then 2 times 1 here, 2 for chlorine on the product side. At this point, the chemical equation is balanced because the number of atoms of each element in this chemical equation on the reactant side is the same as the number of atoms of that same element on the product side. When you are done balancing chemical equation, the next thing you need to write is what we call mole ratio. This coefficient here, you bring it down. 2 ratio. What's the coefficient here? 1 ratio. What's the coefficient here? 2. That is called the mole ratio of this reaction. 2 ratio 1 ratio 2. Another example is on the board. The formation of water. Hydrogen gas reacts with oxygen gas to produce water in liquid form. Let us check the atoms of hydrogen on the reactant side. 2 times 1, 2. On the product side, 2 times 1, 2. So number of atoms of hydrogen is balanced. What about oxygen? 1 times 2, 2 on the reactant side. 1 times 1, 1 on the product side. Therefore, oxygen atoms, they are not equal on both sides. Can we make them to be equal? Yes, we can balance the equation by introducing coefficient 2 here. But when we introduce coefficient 2, it's going to be 2 times 1. 2 times 2, 4 for hydrogen on the product side. Then on the reactant side, 2 times 1, 2. It's not balanced now, so I'm going to introduce coefficient 2 here. Let's check again. 2 times 2, 4 for hydrogen on the reactant side. Then on product side, 2 times 2, 4 for hydrogen. So hydrogen is balanced in this equation. What about oxygen? 2 times 1, 2 for oxygen on the reactant side. Then on product side, 2 times 1, 2 for oxygen. Now, oxygen is balanced on the two sides. What is the stoichiometry? Which is represented as mole ratio. Coefficient 2 comes down here, ratio. Coefficient 1 comes down here, ratio. Coefficient 2 comes down here. So the stoichiometry of this reaction is 2:1:2, meaning 2 moles of hydrogen gas combined with 1 mole of oxygen gas to produce 2 moles of water molecule. Do you have any question?